All right, good morning, everyone. Let's hopefully finish our exercise of zone-based variable rate management that we started last class. So on my side here, I'm going to launch my RStudio project for that exercise. I think I actually already had it launched. So close one of them. And just going to launch my partial script so we can keep going. If you are like on what I'm seeing on my side, where again, my environmental variables are not showing up there, we can just come to the last chunk that we worked, which let's see, I believe was this one here, where we're looking at that distribution of the yield data for the zones. So if you come on the immediate next chunk after that, and you hit the button here, run all chunks above, that is going to run for you and create the variables that you need on your environment for us to keep going. Okay, so one thing, one thing that I just want to remind you all. So again, you do want to make sure that your labels here of what is the high zone, what is the high yield zone, what's the low yield zone, are matching on your side, right? So they could be different colors, but you do want the one from on the left side. So in my case, the blue one here to show on the legend as the low yielding, and the one to the right to show on the legend as the high yielding, as that is going to be important. If you remember last class, we talked about how are we going to determine yield potential. Remember, this is potential, right? So it should be a little bit higher than what you're getting on average, is how much you could get out of that area in a good year. So we're basically using the 90th quantile as we talked about. And on the previous code, for us to do that, we had to have a column with zone. We had to have the columns of the yield for the specific years. So we have all that. We're ready to start calculating here the yield potential and so on. So if we, and again, if you're having issues with your values here being well, maybe I should ask, is anyone having issues here as far as your label of low actually being referred to the distribution on the right? If anyone has that issue, let me know and I can help. And if not, then I'm going to spend time here. All right, so I don't hear anything. I'm assuming you all have something similar to what I'm seeing. So let's get to the variable rate nitrogen calculation. So we talked about before of what is it that we need to determine nitrogen rate, period, right? So not necessarily a variable nitrogen rate. In our case here, we are calculating that for two different zones that we derive from this field. And if you remember, one of the things is the yield goal, right? So that's why the first step we're going to do here is to calculate the yield goal, which again is the 90th quantile of the distribution separately for each one of those density plots. So let's do that first. We're going to, on this, if you come to the next chunk here, give the assignment symbol. We're starting with the object zone yield, which is the one, just to remind you, is the one that we joined on this chunk above, where we brought in the labels for the zones and joined spatially with the yield data for 17, 19, and 20, which was interpolated, meaning that they all have the same number of rows, same number of cells or mini polygons on that map. So we're starting with that. So here is, I'm just going to print zone yield below so we see it. We can create the understanding of what we're doing. So zone yield on my side has 4,046 rows. We have this column here for zone that has values saying either low or high. And then we have the three yield columns here. If I want to calculate the 90th, so let's think about it. If I want to calculate the 90th quantile across all 3 years for each of the zones, so for each of the two zones that I have on this column, what should I do immediately next step here? If that's my goal. Okay, so group by zones. We will group by zone at some point, but there's something else we need to do before that. So maybe let's start with what Ujjwal is saying, and we can see what happens, right? So if we just come here and do a group by, and the name of the column on this object zone yield is zone, right? So let's group by that column, group by zone. And then Ujjwal, or maybe someone else, what would you do after this group by zone? How would you, so remember, yes, somebody online said something?
I was gonna say select, but I
So select is what we use to select specific columns, right? So in this case here, the idea is that we want to extract a statistical summary variable, right? Which is the 90th quantile. You can kind of think of it as if we were extracting the mean. We can think about it from that perspective, and we get there, you're going to see the difference. So what would I do here if I wanted to get the mean yield by zone? Summarize, right? So let's do that. So summarize. So I'm gonna show you here already the function that we use to get the 90th quantile, so you don't have to rewrite it. Even though I do want to tell you that we're still missing a step, and I hope we're gonna be able to see what is missing when we do it. So assuming this code here is going correctly, we would summarize to get the 90th quantile. I want to call this new column that we're creating as yield potential. And this is basically, we're gonna use the function called quantile, which is a function in base R, where the way this function works is you give the name, so X and Y. The name X here is the name of the column that I want to extract the quantile of, and Y is what is that quantile. So just so we have some idea, what is a quantile? I don't know, just to refresh our heads here. So if you take your data and you sort it from lowest to highest, the quantile is whatever value you have on a given position of that lowest to highest. So for example, if you get the 50th quantile, that is called the median, right? That is what the median is the 50th quantile. And so in our case, we want the 90th quantile. So it would be the 90th position if you sort your yield values from lowest to highest. So here on this Y, I mean, the name of the argument is not Y, I guess it's just a placeholder for us to create the understanding. But there's an argument called probs that I want to say that goes from 0 to 1, where 0 is the 0 quantile, 1 is the 100th quantile. So if I want the 90th, I would say 0.9. But now X should be where we give, so this first argument is the name of the column over which I want to extract the 90th quantile. So let's just take a look right now on what we have on zone yield, which is the data coming in. So which column here would you extract the 90th quantile of? Yes, exactly. So Ujjwal just said, maybe we need to pivot longer first and then get the 90th quantile. And that's correct. So I do not, in this case, I want the 90th quantile of yield across all years. I don't want a 90th quantile for 17 and then for 19 and then 20 separately, right? I want them all in one column, have all these yield data values for all 3 years, and then extract the 90th quantile of that distribution, which is what we did on this plot, right? So we did a pivot longer here, and then we plotted this. So yeah, we're missing that pivot longer. So I mean, if you want to come back to the previous chunk, you can just copy that pivot longer because it's going to be the same. And you can just paste that right before this group by. So what I want to show you here is, so zone yield in my side, I have 4,046 rows. If I stop the flow at this pipe, so if I comment this pipe off, it's going to stop right here because I want to show you what happens when we pivot longer. And I print to VRN, so object, so you see. So now we have, if we went from 4,000 to 12,000 rows, that's because before we have 3 columns with yield, and now we basically stack them below each other. So 4,046 times three, that's the 12,000 there. So, and then we have a new column that has the name, which is where all the previous column headings are now. So the column headings previously were yield 17, 19, and 20. And then their values are all under the same column now that's called value, right? So we want the 90th quantile of this column here that's called value. That's what we're looking for. And then, of course, by zone, which is what we're doing when we establish the group by. So if you come back to the code, I will uncomment my pipe. If you had commented, you're off. Make sure you uncommented. So you let it flow to the next line. And then here on the quantile, we want to give the name of the column, which now is called value. Right? So if we run this, and then you print the VRN object, we should have 2 rows because so remember, if you do a group by and summarize, you should expect to have fewer rows, right? You're going to have 1 row for each level of the grouping of the group by variable, right? So our group by variable was zone. We had a high and a low value. So then that means our ending result of this group by summarize gives us 2 rows where we have the yield potential, in this case in pounds of lint per acre, of both the high zone and the low zone. And I just want to, so we can visually, I guess, see what this means. If we were to come back to our plots that we just made on the previous chunk, let's just add a geom here so we can visualize where are those 90th quantile for each one of these distributions. So if you go back to the chunk, add a plus, there is a geom called geom_v line, which is when you want to add a vertical line. I want to add a vertical line right at the 90th quantile of each of these 2 distributions. So if you just hit tab, it's going to have this argument called x-intercept. So this is where in the x-axis I want to have vertical lines. So I want this to be equal to our yield potential, which we can access that by just calling the object VRN, which we created, using a $sign and then asking for that yield potential column. So if you just do this, this is what we get. So that's where the 90th quantile of both of those distributions is. Let me show you the code. Okay, so this was just for us to visualize where those values were. Yes.
So I'm gonna do my high yield potential 1,892 and low was 1,892.
Okay, so they're really close. Is that what you're saying? Like, interesting. Is anyone?
That if I messed up, I have my high wrong because it's 1 on each other.
So I wonder, because like, so in my side, I guess they're just about 300 pounds of lint per acre difference. But in your side, you're saying that they're like 1 pound difference. Yeah, I'm not sure what would cause that. Because like, even if you, so let's say in my case here, if I had flipped, because remember that the result from the k-means is just cluster 1 and 2, right? And then we looked into all the previous variables to assign a label of higher or low yield. So even if I had like confused on my script and I had labeled them opposite, they will still be different, just with a different label, right? I mean, there will still be, the yield differences will still be the same, but it's just the label that would have been flipped. So on your side, for the actual yield values to be the same. Yeah, it's kind of curious. I'm not sure what's going on there. Well, is anyone else, so I guess maybe we can go around just quickly and having some idea, like, if you just like ballpark difference, what is your difference between yield of the high and the low? Like how many pounds? In my case, the difference is about 300 pounds of limb per acre. What are you seeing usual?
Trying to go on the code.
Okay. Let me show you. Renalisa, what are you seeing? 400 difference? Sandes. Okay, and then Doug is about 1. Let's see online. Kumar, what is your difference there?
In which you are asking for the difference?
Yeah, so when you run on your side, what is the difference between the yield potential, the high and low zone? Like in my case, it's about 300 pounds. What about you?
Let me see. 600, 300, almost 300 and something.
Okay. Let's see, in Tifton, I think, is that Clint and Vinicius or, yeah,
Yep, yes, sir.
yeah, what are you guys seeing there?
Well, I got 280 around.
What about you, Clint?
I'll be honest with you, I'm just following along. I'm still trying to get caught up from missing last week.
Okay, no worries.
But so I'm following along, but I don't have it actually like pulled up and run.
Okay, no worries. Rolando, what about you?
It's 320. That's the difference.
Okay, so Doug, it seems like it may have been something that happened on your side. I can help you to troubleshoot that after class. But yeah, I mean, even though this difference is not huge, but you know, we will likely see some difference here. Yeah, so maybe let's just keep going with the exercise and then we can try to troubleshoot on your side after class. All right. So all right, so we have the yield potential, right? And that was the one of the most important pieces of information that we needed on that UGA FERTEX to come up with the recommendation. So let's go ahead and add a pipe here. And our next step is going to be to actually use this yield potential and figure out what would be the nitrogen rate that we should apply here. So I have a note here for us to go on UG FERTEX, enter these yield potential values, assuming cotton as a previous crop, irrigated, coastal plain soil. What total nitrogen did you get for the zone high yield or for the high yield zone? And what about for the low yield zone? So let's go ahead and do that. If you go up on the script, I have a link for the website. Let's see. Right here on around line 36 of the script. I mean, you can either copy that or maybe you can also, you know, just Google UGA, UG FERTEX, you would be able to find it. Right, so if we come on UG FERTEX, you go on inputs, just like we did last time. So our crop is going to be cotton. Our soil is coastal plain. It is our previous crop. We're going to say, oops, not grain sorghum. We're going to say is cotton as well. We're going to check the irrigated box. And we're going to change here our yield potential. So I will let you do that. I will return to the script. And I guess, let me see. You know, you can enter your own values rather than me entering mine. I mean, rather than you entering my values as well. You can just enter on your yield potential values on your side, but you're going to have to keep track of that because they're going to be different from what I'm going to show you on my side because I'm showing you my values. So just keep that in mind. But if I were to enter my values here, let me go back to that. That would be, well, 1986 for the high zone. So that would be my yield potential here, which is giving me 135 pounds of nitrogen per acre. I do want to ask you to take note of that value on your side on the script. So for me, this is what I am doing. I guess, Doug, in your case, if you want to follow what I'm doing on my side for now, just so you have you can work along, but then afterwards we can figure out what happened with your yield. Yeah, 1,986 is my yield potential for the high yield zone, which is giving me a recommendation of 135 pounds of N per acre. So I want to take note of that right below my chunk here. So high yield zone and rate is 135 pounds of N per acre. And then my low yield zone and rate, I'm gonna figure out right now. So my low yield zone is 1,682. If we go to here and just change the yield goal, then this gives me a nitrogen rate of 115 pounds of nitrogen per acre. All right. So we figured this out, the rate for our zones. And now I want to show you a trick, or not a trick, but a tip or a way to perhaps automate this a little bit. So behind the scenes, what Vertex is doing is you're giving that yield potential and it just has a regression line, right? It's just a regression line that as you increase yield goal, your nitrogen rate increases by a certain amount, which is the slope of the regression line. So if we wanted to, I guess, not have to go do this manually on UG Vertex, you could just bring that regression equation here and apply that to your yield goal, and you will have that total amount of nitrogen already, which is what I want to do on this next chunk here. So the chunk that has, or sorry, not chunk, but the next part of the code here, where it says we can also calculate those using the formula below, which is the formula used behind the scenes on UG Vertex. So I left you the mutate there. I left you already the name of the column that I'm giving, just so we avoid confusion of, maybe people write this differently. So I want to create this new column in our data set that we're going to call total N rate in pounds per acre. Let's just give it an equal sign. And I'm going to put here the equation of what is actually going on behind the scenes on UG Vertex. So that equation is 15. So 15 here is the y-intercept. So 15 plus your yield potential, which in our case, we already have a column with that name, which is that yield potential that we created above. So yield potential times 0.06. So 0.06 is the slope of this regression. So 15 is the intercept, 0.06 is the slope. So if you want to just check this, I would say comment, add a hashtag right before the pipe so you avoid it from connecting to the next line of code, and just run it until here. So it stops here, and then you can print VRN just to see what that turned out to be. If you come to the right, so I have my total nitrogen rate for the high yield zone to be 134.17, which UG Vertex is just rounding that up for us. And my low yield zone nitrogen rate is 115, which UG Vertex is rounding down for us. Right, so really behind the scenes is just this equation being applied. That's what we're getting. I would imagine that on your side, you're also getting very similar rates from what you got from UG Vertex and what you're getting here on this column. All right, so let me just plug my power cord here very quickly, and then we're gonna keep going. So remember that we talked about what are the things that impact how much nitrogen we should apply. The main one was yield potential, but then we have these other components that are differentiating or they are modulating that total nitrogen rate. So one of them, if you remember, is that we should adjust our total rate in 25% upwards if it's cotton following cotton. If you were to go back to UG Vertex, I don't think it, even though, it's interesting, but even though he has this prior crop option here, I don't think it is adjusting higher. Perhaps it's just decreasing if you add a previous. Yeah, so it gives you a credit if you have a previous legume, but it does not give you a penalty if you have previous cotton, which is what, if you remember on the cotton production guide, it says you should do. You should decrease the rate if you have previous legume because you have the nitrogen credit, but you should increase the rate if you have previous cotton, which is not happening here. UG Vertex is not doing that for us. So let's do that manually in R. See it pulled up there, the wrong one. There we go. Okay, so if you now allow that pipe that we just commented off, uncomment that so it goes through the next line, we're going to adjust the rate upwards, and I'm calling that total end rate adjusted pounds per acre. Let's just give it an equal sign, and really all we're doing here is getting the previous column that we created, total end rate in pounds per acre, and just multiplying that by 1.25. So this is gonna increase that total rate in 25%, right? Very simple math. If I just add a, if I just comment off here, just so we can run and print to see what that becomes. So I just ran until here. I'm gonna run and print the object VRN. If you go all the way to the right, now we have this total end rate adjusted, and these are the rates that we have right now, which are 25% greater than what we had before. Again, we're doing this because cotton production guide says that if we have cotton following cotton, we should increase in 25%, and we are assuming that's our condition here. We have cotton after cotton. All right, so this is our total rate, right? So this is the rate that we should apply in total for the growing season. If you recall, on the UGA cotton production guide, it recommends that we apply a third to, one third to 1/4 at planting, and then apply the remaining of that at side dress, which is between first square and first bloom, right? So in our case here, what we're doing is we want to apply a fixed rate across the field at pre-plant or at planting, and then really allow the side dress application to be variable rate based on our zones. With that, let's just calculate a pre-plant rate for both of our treatments, or I'm sorry, both of our zones. So if you come here, let your pipe flow if you had commented that off. So let it flow to the next line of code, where we're calling PP for pre-plant total end rate adjusted pounds per acre. So this is basically going to be our total end rate adjusted pounds per acre that we just created on the previous step times 0.33, which is a third. So I want to do that. I will add a hashtag to my pipe so I can run until here and inspect. So if you print now VRN, it says that we should apply 55 pounds of N per acre pre-plant for the high yield and 48 for the low yield zone. Because again, our goal here is not really to have a variable rate at planting, just at side dress. We're gonna assume just one of these values for both of the treatments. So I have here that on my script, I selected the 47. I guess it doesn't really matter much in this, especially in this case, since they're so similar. We could select the highest one. So maybe let's select the highest one and just apply you know, the maximum that's gonna be needed at planting across both of the zones similarly. And then just come side dress and do variable rates. So let's assume that we're applying 55 pounds of nitrogen per acre at planting to both zones. So if you come here to the script, on this next chunk here, so, okay, so let me just take one step back. We just determined how much is gonna go at planting, and it's gonna be the same rate across both zones, and that's gonna be on my side, 55 pounds, on your side, it can be whatever value you found for the highest zone. Now, the in-season application, so the side dress, the application we're doing between first square and first bloom is gonna be the difference of the total rate of that zone minus the fixed rate at planting, right? And that's what we're gonna be calculating next here. I have IS to mean in-season, total in rate, adjusted pounds per acre. So this is basically going to be our total nitrogen rate. Well, let me come here. So the total N rate adjusted pounds per acre, right? So the total we're needing minus what we're applying fixed rate pre-plant, which is 55, which I just got from here in my case. So again, the 55 is a fixed number that I'm giving it because it's gonna be fixed for both zones. We're just allowing it the side dress rate or the in-season rate to vary according to zone. So if I just add a hashtag here to allow it to run until here. Oops, I'm missing. All right. So make sure that if you had your hashtags before the pipes, you just allow that to flow until this piece of code and then block it from running after this. So we can run that object and then print so we can see what that is. So our in-season here has become 113 pounds of nitrogen per acre for the high zone, and then about 90 pounds of nitrogen per acre for the low yield zone. Right, so remember that they're both receiving a fixed rate of 55 pounds of N per acre at pre-plant, and then the side dress is what is being allowed to change here. Okay, I guess any questions up until what we've done here? Quickly recapping, on this chunk, we started with the object that had all the data for the field for yield in 3 years. We pivoted that longer, we grouped by zone and extracted the 90th quantile per zone as the yield potential. We used that in this equation here to get a total nitrogen rate for each one of the zones. Then we calculated, we adjusted that zone 25% upwards because we're assuming it's cotton after cotton. Then we calculated the pre-plant application. So the total is going to be split between a pre-plant and an in-season or a pre-plant and side dress. The pre-plant is just 33% of the total rate. The remaining of that is what goes on side dress in season. So it's just the difference of that total and rate minus the pre-plant, which we determined would be a fixed rate for both of the zones, because our goal is not to apply a pre-plant variable rate, it's just an in-season variable rate. And then we come up with our in-season total nitrogen adjusted per zone. All right, so the next thing here is, so we just created our prescription for in a pounds of nitrogen per acre basis. However, a grower will most likely not use that column directly when they're doing an application. They're gonna have a specific nitrogen fertilizer source that they're gonna be using, and they're gonna be applying a rate of that source, right? So in this case here, I am assuming that we're gonna use a liquid nitrogen source called urea ammonium nitrate, UAN for short. UAN has, in the market, you can find it in 3 or maybe more than 3 different concentrations of nitrogen that can range from 24% up until 32%, depending on where you buy it from. So I'm gonna propose that we assume that this grower is using a UAN solution that has 28% of nitrogen concentration in the product, right? So how do we go here from pounds of nitrogen per acre to gallons of UAN per acre? So going from pounds of nitrogen to gallons of UAN. We're gonna find that adjustment component on the chunk below. So if you come here, if you think about it, we're gonna need to know what is the density of UAN, because I need to know how much does UAN weight, so I can put use the weight of UAN to put that nitrogen weight into a basis of solution, right? Which the density is what's gonna help us with that. So if you're looking for this, if you're working with any liquid fertilizer or really any liquid agricultural product that you're trying to determine going from pounds of a nutrient or an active ingredient to gallons of a product per acre, we need the density. If you just do like a quick search, what I did here, I just went on Google and asked for UAN 28% density. This information here is normally found on the label of fertilizers, or if it is like a lab chemical, it's going to be on the MSDS information from the manufacturer of that reagent. I found a couple here that I left you the links. I just want to show you one of them. This again was just a Google search. There's nothing special necessarily about these ones I'm sharing with you, but are just examples. So this is the safety data sheet for urea ammonium nitrate solution by this company, Agrico. It is at 28%. And again, here you can see that they also sell 32% nitrogen. If you have a different nitrogen concentration, the density is going to be slightly different. So especially if you're working with UAN, pay attention to that component. But so if we come here, let's see, where is that information? So they're going to have the density information somewhere. Composition. Let's see, where would that be here? Storage. Okay, so physical and chemical properties is probably going to be somewhere here. All right, density. So that's what we're looking for. So at 16 degrees Celsius, 28% UAN has a density of 10.67. And in this case here is pounds per gallon, right? So this is where I would get this information. This is how we would look for that if you have this application in a different setup. So that number 10.67 is what we were looking for. So I just left you here all the formulas. I'm not asking you to do anything with it, but just this is how you would go from using the density to go from pounds of nitrogen per acre, which is what we know we need, to gallons of UAN 28% per acre, which is what the grower is going to need from you. So here I'm just assigning these values to different objects and giving them names that we can understand what that means. So UAN 28% density in pounds per gallon is 10.67. So 10.67 pounds per gallon. Just going to run that object. I know that the concentration of nitrogen in UAN 28% is 28%. So 0.28 is that concentration. To get the pounds of nitrogen per gallon of UAN, we just multiply those two things, right? So I know I have UAN in pounds per gallon, and I multiply that by 28%. So I get pounds of nitrogen per gallon. And then if we just print this object here, that's going to be about 3 pounds of nitrogen per gallon of UAN 28%. So this is the value now that we're going to use to go from nitrogen rates in pounds of nitrogen per acre to gallons of UAN per acre, right? So remember this number 3, we're going to use 3 just for simplicity, came from these calculations. So if you go back to the previous chunk, that's what we do in that last step right there. So I'm just going to allow that pipe to flow to the next chunk. Going to give an equal sign. And the UAN rate that we're going to be recommending in gallons per acre is just going to be that total in-season apply rate, which we just calculated above, divided by 3. And 3, because it's again the number that we calculated on the chunk below, that's the conversion factor to go from pounds of nitrogen to gallons of UAN per acre. So it's gonna be this IS total and rate that we just calculated on the code above, divided by 3. So if we run this and we print VRN, we have now our UAN rate in gallons per acre for each one of the zones, being about 38 if we round it, gallons per acre on the high yield zone and about 30 gallons per acre on the low yield zone. Something else, the last step I want to do here is just a little bit of a cleanup where we're going to be making maps with these values. And right now they have too many decimal points, more than what I wish. So let's just round them to have 1 decimal point. So we can come here on the same mutate, just give a comma, copy again that same column name of UAN rate, gallons per acre. We're going to use a function called round. Give that column again, so round UAN rate in gallons per acre, comma 1. So we just get 1 decimal point on that column. If you run that and you print it and you inspect, now our UAN rate only has 1 decimal point. You know what? It could even be just 0 decimal points, I guess, for that matter, just to simplify even further. So we're applying 38 gallons in the high yield and 30 gallons per acre on the low yield zone. All right, any questions until here?
Can you show me the last code? I'm still there. Okay, thank you.
Awesome. Okay, so now we know the rate that should be applied so the rate of UAN in gallons per acre that should be applied to this field. So here's a question for you. I want someone or maybe more than one person to help me here. So if I give this recommendation or this prescription to a grower, they're gonna have to order fertilizer, and that fertilizer has to be delivered to the field before they can apply it. Meaning that they're gonna have to have some idea of how much fertilizer they're gonna need for this field to be delivered. Right now, I have I have gallons of UAN 20% per acre. What do we need to do for this grower to call their co-op and say, hey, I need this amount of UAN to be delivered so I can make this application to this field? How do we go from this rate to the total amount of UAN that they need to order for this field?
You need to calculate the zones area.
Okay, and then what do we do with that?
And we're gonna multiply by the rate that we need.
Yes.
And gonna 2 steps because we need for the planting and for the second application for the side dress.
Yes, that's exactly right. Thanks, Vinicius. So if you think about it, we need to know what is the area under each one of those zones, right? So let's say we're gonna have to know how many acres each one of the zones have, and then multiply the acreage by the rate. That would give us total gallons of UAN that we need per zone. And then we can just combine those 2 numbers and say, this is how much you need for the whole field, right? Okay, so let's go to the next chunk and do that. So we're starting off with the object VRN. We're not assigning anything to it, so we're not creating any new objects. I just want to use it to do some calculations. So we can give it a pipe. And the first thing that we need to do here is calculate the area of these zones. So something very interesting that I don't think we have done yet is, even though we did a group by and a summarize, but VRN, if you print it and you inspect it, is still a simple feature object, right? It did not just drop the geometries. It still has 2 geometries here. what happened is that when we do a group by and we summarize on an SF object, all the components that before were different polygons within that larger field, now they're still there, but now they're grouped, right? So now the SF object knows which polygons are high, which are low, and they group them into one line of geometry here. So we still have all of those geomes that we had before, but they're just grouped into the different zones. With that, I mean, that in itself, it just matters because to say that we still have a geometry here, we still have that spatial information. And whenever you have spatial information, it's very easy to calculate area. So let's go ahead here and do a mutate. I want to call this area underscore M2 for meter square. And it is going to be meter square because the CRS of the VRN object is projected UTM in meters. So the area that we get back from it is going to be meter square because of that. So there is a function from the SF object called st underscore area. And we just need to give a dot here. So we get that back from each one of the zones. If you just run that, and you come to the new column that was created, we see here that the high yield zone has about 230,000 meters squares, and the low yield zone has about 173,000 meters squares. However, our rate is on an acre basis, right? So we're going to need to transform this area for each one of the zones to an acre basis. So let's do that in the next step here. Let's call a mutate. I want to call this new column here as area underscore AC for acre. And let's do here, the way to do this calculation is just get the area underscore M2 and divide that by 4047. So that's the conversion factor to go from meter squares to acre. If we run that, and then you just inspect your object here. Now we have our area in acres. We see here that the area in acres for the high yield zone on my side is about 57 acres and about 43 acres for the low yield zone. So now we have a column that has the acreage here. Another example I want to give you here of using this function is, let's say when you do your boundaries and you want to know how big is this field, just so you have some idea, you can easily just bring in your boundary and give this st area function to it. It's going to return you back, again, in meter squares, but you can do the transformation to know what is the acreage of that boundary if you want to know from that field. One last quick thing that we have to do here before moving on is, so when we use this function st area, maybe, I don't know if you noticed, but it has a different object type. It's calling this an unit type, and it's already adding for you the meter square by default, which is okay for the initial area in meter squares because that is meter squares. But the second one that we did the transformation, even though we know that number is acres, but that column type is still of a type units, and it still says meter squares, even though it's not anymore. So just so we don't get confused on these units and look back and say, well, is this meter squares, is this acre? We're just going to force this column to be numerical. So it's going to stop being seen as a units type of column, and it's going to drop this meter square on this column here. So let's just, if you go back to the chunk, we're just going to be right before the area meter square, we're going to ask for a function called s.numeric. And then open parentheses and make sure you close at the end. This is just going to force this column here to be seen as a numeric column and not a units column. So then it becomes a double instead of units. All right, so let's give it a pipe here. And what I want to do next is I basically So for us to know now how many gallons of UAN we need, as Vinicius said earlier, we just need to calculate now the rate that we calculated for each one of the zones by the area of those zones. They're both in an acre basis, so it's just a very easy math. For this case here, Vinicius, so you made a good point of like, if we wanted to know the total, including the pre-plant and the side dress, we would include both of those rates. And then ask for that amount. I guess in this exercise, I'm showing here, the way that I'm showing the calculations is just using the rate at side dress, and not including the pre-plant. But, you know, in any case, if you wanted to include the pre-plant, it would be pretty simple to do that as well. So let's do here a mutate. I want to call this next column here UAN underscore gal for gallons. So this is basically just going to be our, let me print VRN here so we can remember. If we go all the way to the right, we have this UAN rate in gallons per acre. So that the total UAN is just going to be the rate in gallons per acre times the area in acre. So if you run that and you inspect your column, your last column that we just created, these are how many gallons you would need per zone. Gallons of UAN 20%. I do want to increase this in 20% just so we have a little bit extra than what we need. In case, you know, something happens, you have to calibrate equipment, you have to do something more. So we always want to have a little bit of a buffer there. So I just want to wrap this around parentheses and just multiply that by 1.2. And then remember to close the last parentheses again. So this is just going to give us 20% more of what we would need to apply to the field. So we have that little bit extra buffer. So if you run this and you inspect your last column, those are how many gallons you would need for each one of the zones. So, you know, I know different people may have seen this different number of times, but remember that a rate is always based on an area component, right? So pounds of nitrogen per acre or pounds of lint per acre, that's yield. Not to be confused with the total amount that you get, right? So let's say something that I see some students getting confused by is the term yield and production. Those things are different, right? Yield is how much production you get on an area basis. So it's how much production you get per acre or per hectare or whatever that is. Whereas total production by itself is the total weight or volume of something that you got not on an area basis necessarily, right? I mean, it could be like on a field, right? So on this whole field here, I got X pounds of lint total, not per acre, but total, right? So just, I guess that distinction is what we're making here as well. We have a rate that's based on area basis, so per acre, but I want to know how much total I need for that piece of land. That's our total amount of UAN. So it's not a rate anymore, it's a total amount. All right, so now I know how much UAN in gallons I need for each one of the zones on a gallons basis. But really, you know, when the grower is gonna make this order, they don't care at this point how much is going to each one of the zones. They just need a number so they can call their co-op and say, hey, I need at least this amount to be delivered so I can make this application. So how can we get the total for the field, not on a zone basis, but for the whole field? What would you have to do here? What function would you use? So right now we know how many gallons we need per zone, but what if I want to combine those into one number and say, this is how much you need for this field? Just some, right? So we can do that. Of course, in this case here, it would be simple, I guess. We could just add them easily. But I do want to show you how we do that programmatically, because if you do have more zones, if you do have multiple fields, you know, the more you can automate the process of getting there, the easier your life becomes. So let's add a pipe here. So what function do we need here? So it's not select, so select is like selecting columns, right? It's something else that we have already used today. So let's think about it from this perspective. Every time that you want to get a statistical summary, which could be the minimum, the mean, the median, the maximum, standard deviation, the sum, all those things are statistical summary functions. Every time you want to get that from a data set, and in the end, you expect to have less rows than you had originally. So in our case, I want the total for the field, right? Which is going to be one value. So you're applying a summarizing function and you're expecting to have less rows than what you are given that function. I want you to think of summarize. Okay, so summarize is the function we're going to need here. Let's call a summarize. I want to call this total UAN underscore gal for gallons. So this is just going to be the sum of that column UAN gal. So if you just run that, it should return to us just one row with that total amount. Right, so this is how much that grower would need to order, at least this much, to be able to make us apply this fertilizer side dress application to this field that we just did for your end. Right, so this is how much total UAN that grower would need to have by the field so they can make this application. Any questions here?
Professor,
Yes.
I did not want to interrupt you there, but can you go back to the chunk in 175? Because I think I missed something and I keep getting this error, so that's 177.
So it may be a little bit different than on my side, the number of the line code on yours. But are you seeing what you need?
Yeah, so 175. So you did add a different code over there. UN rate Galac equal round, right? You round it up over there
Mm-hmm.
to 0.
Mm-hmm.
Okay. Thank you.
Yeah, no worries. Any other questions or maybe issues with code? All right. So I don't hear anything. Let's keep moving here. Something I really want to, stress this. So we did a lot of things. We did a lot of calculations. It seemed like it worked, but always make sure that you plot what you're doing so you can actually check visually if things make sense, right? Because things can happen when you're just doing, different steps here. And you may make a mistake without realizing, and the only way to realize is when you plot that somehow. So that's what I want to do next, is to make a plot. I want to create a map of this variable rate application recommendation that we're creating. So if you just think about it, our VRN here, so I'm just going back to the chunk where we created the VRN itself. So here I do have, the information. So really what I need from this at this point, all of these columns in between the last one and the first one are just intermediate columns that we did step by step to get there. It's almost like you can think about it if you use Excel, these would be different columns in Excel, right? You have a formula here, a formula there, until you get to the end, which is what you need. So really what we need from here is the UAN rate and the zone. That's all I need at this point if I want to make a map of this. So what I want to do at this point is just to combine this result of the UAN gallons per acre for each one of the two zones with our original zone yield object, which is the one that we started on the top here. Well, the zone yield object has 4,046 rows, has all the information that we brought in from this field as far as the zone information, the yield as well across 3 years. I just want to have another column here that says zone, and it gives me low or high. Maybe there are a couple of different ways we can do that. I want to show you one of them, which is what we're going to do on this immediate next step here. So I want to call that VRN_V as the object. I'm going to start off with zone_yield, which is that object I just showed you with 4,046 rows. And now my goal is to have a rate for each one of the zones on this object, which we do not have yet. That information is on the VRN object. So we could do a couple of different types of joins. I want to show you here to do a left join. So we're going to basically ignore the spatial component on this step, and we're going to use a left join, which has no regard for spatial information. It just uses two columns with the same name to match. So I want to do a left join on the VRN object. However, VRN object is also an SF object at this point. I do want to transform this VRN just into a data frame. So basically forgetting about the spatial information that it has. To do that, we can add a pipe here and add a function st_drop_geometry. If I just run here VRN and st_drop_geometry, this is what happens. It drops the geometry. It kind of forgets that was a geospatial object. I just get a table where I have all the columns that VRN had. The ones that I care about really are just zone and UAN rate gallons per acre. So if we do this left join, what's going to happen is it's going to look into zone yield, and it's going to find that zone yield has a column that's called zone that has the values low and high. It's going to look into VRN st_drop_geometry. It's going to see that it also has a column called zone with the values low, high and low. And it's just going to basically repeat all of these other values here on VRN into the zone yield. So every time that on zone yield it has zone equals high, it's going to repeat these values here for these columns. And when it's zone low, it's going to repeat the zone low values. So if we just do this left join and we inspect the VRNV object, we should still have the same number of rows as zone yield. Remember, we're doing a left join, so the data set on the left is zone yield. But now we have more columns here. So if we just browse to the right, we now have the yield potential column. All the columns that were present on the VRN object are here, and those values are just repeated, right? So every time the zone was equal to high, it just repeated all those high zone values. Every time it was equal to low, we just repeated those values there. So that's what happened here. Okay, so now we have one object that has all the information together, combined. And now I want to make a plot of using that object. So VRNV, which we just created above, is still an SF object, so it still has spatial information. It has all those columns. And my goal here is to make a map that I can show this grower that includes the UAN rate that we're applying. So not the nitrogen rate, but the UAN rate. I'm doing a little bit of a wrangling on the go here, where I'm, so VRNV, if you look into VRNV, that UAN rate to gallons per acre column is numerical. Just go all the way to the right, that is numerical. I just want to transform that to factor because that changes how ggplot assigns a color scale. If it is numerical, it's gonna try to give you a continuous color scale. If it is a factor, it's gonna give you a divergent color scale. I mean, not divergent, but a discrete color scale. So that's the only reason why I'm changing that to factor right here. I'm plugging that right into a ggplot. And I left you a blank space here so you can help me to determine what geom do we need here if I want to make a map that I fill the polygons of the map with the rate in gallons per acre. So what geom do we need here? Clint, what do you think?
Would it be a geom SF?
Yes, that's correct. So let's go ahead and do a geom SF. What I want to say here is I want to go into the AES to say that I want to have the fill and the color of those mini polygons to be according to the UN rate gallons per acre. So we're just going to come here and say fill equals to UAN rate gallons per acre, and color equals to the same variable. After that, make sure you add a plus to connect with the remaining code there, which I'm just giving a title and then changing the title of the legend to say this, UAN rate in gallons per acre, and then just applying the my theme map object that we created in the first place, or in the beginning of the script. If you just run that, this is what we see. Right, so we have a map that was based on our zones, that we associated the zones with yield and determined what was the yield potential, used the yield potential to come up with how much nitrogen was required, and then determine what was the rate in UAN in gallons per acre to this field. So this would be a visual of this map or of this prescription that we're giving to this grower here. And, so you can think, so this process that we just went through, we used this in terms of nitrogen. And when you think about it, nitrogen is one of the nutrients that the way we determine the rate is not necessarily the most important factor impacting the nitrogen rates is the yield goal. Because we're using yield goal, we need to know what is the yield potential of these areas, which we did using the yield data that we clean interpolated, and we then extracted that information per zone. If this would have been a different nutrient, so if this would have been phosphorus, potassium, perhaps if you had a pH map and you're trying to make a line recommendation, the process would be very similar. The difference then is that you would not use yield goal as the variable determining the different rates. You would actually use the soil test values, right? So you would use, let's say for a nutrient, you would go to this field, you have an interpolated map of, let's say, soil phosphorus or soil potassium, and you know what crops are growing here. You would have a number of how many pounds of phosphorus or potassium is required by that crop to optimize yield. Even though we're still optimizing yield, but yield is not the main variable going in here, it's more the soil test value. So you would say, okay, I have parts of the field that the amount of phosphorus or potassium is below what the crop requires. So I'm going to apply the difference to make it up for it, right? So so the main layer then becomes your soil test values and not yield goal as we use for nitrogen. Very similar with pH and lime. So you have a pH map. You have formulas that relate your current pH, your target pH, and how much lime you need to apply to get there. These formulas, all these recommendations, you can find them in the production guide. I think UG Fairtex also helps you with that. But the process we did here, even though it was for nitrogen, is very similar, regardless of what it is that you're applying based on zones. It's just that, perhaps you're going to create the zones using different variables, and perhaps you're going to create the recommendation using a different algorithm, but the process overall is still very similar, right? So I just wanted to expose you to the process of coming up with. So really, if you think about it, we went all the way from having yield data in 3 years. We wrangled, cleaned, interpolated. We brought all the soil variables based on terrain variables and soil electrical conductivity. clean interpolated, brought all those variables together, did the yield spatial temporal analysis, did the management zone based only on soil variables, validated them, determined how many zones we needed on this field, determined what was the yield potential, created a variable rate recommendation based on those zones. That is a full circle of something that's very commonly done in Precision Ag, right? So with that, we wrap up a very important, workflow, very complex but important workflow in Precision Ag that could be applied really in research, could be applied in production. It's really a common workflow to have. All right, any questions, I guess, about all this? All right, so I don't hear anything. Let's keep moving here to wrap up this exercise. So the last thing here is, if you were doing this and your goal is to actually apply this variable rate map or recommendation that we just created, we have to export it. And this is going to be the first time that I'll be telling you for us to export this as a shapefile. Right, so I think that when you are working internally, like you with yourself, or maybe with a colleague that understands what's being done, GeoJSON is really helpful because it keeps your files to a minimum, right? You don't have all those extra shapefile associated files floating around. It's easier to create, to export, to share. Now, most growers are going to be using equipment that I actually don't even know if those equipments understand and read GeoJSON, but for sure they do read and understand shapefiles. So if the goal here is for a grower to implement this, we want to export that as a shapefile to share with them so they can actually use this on their equipment. So that's what we're going to do here. What I would recommend, and I want you to do with me, is, as you remember, when we export this SF object as a shapefile, we're going to create, I think in this case, at least 4 files that go with it. And I do want to have that a little bit more organized. So what I want for us to do here is to come on your Files tab, click on the R blue button to go to the home of this directory of this project. Let's go on that output folder, which is where we want to export this. In this case, there's really nothing else in this output folder at this point. But let's say that there was other layers here. I don't want for our shapefile files to just be mixed with other files. So I would propose that we come here and we create a folder that I want to call. So if you just click on that button right there, it allows you to create a folder. I just want to call that VRN. So this folder is inside outputs, right? So in outputs, I created a VRN folder, which is where I want to export the shapefile. So it's contained in one subfolder, right? It's not just mixed with other potential files in the output folder. So if we come here to this next chunk, let's just add a pipe. So something to think about it. VRNV has 11 columns. Really, all the grower cares at this point is going to be to have so they need a geometry. I mean, we need that to create a shapefile, but what they care is just the UAN rate column itself. I want to give here the zone and the UAN rate just so they can look and make sure that that's matching on their side when they're applying it. But they really don't care about any of the other columns here that were important for us when we're creating, but not for them. So if I want to only pick a couple of columns out of the 11 ones that we have, what function do we need? Let me see here. Let me ask.
Selected.
Yes. So was that Hejimar?
I think as dplyr and select.
Yes. Thanks, Hejimar. That's right. So just to refresh again, if we want to pick a few columns, we use select. If we want to pick different rows, filter. If we want to create new columns, mutate, right? So a few concepts there. So as Hejimar said, thanks Hejimar, we're going to use dplyr : select to only select the zone column and the UAN rate underscore gal AC. Because this is an SF object, the geometry comes by default. Even if you say that you are not selecting the geometry, it's still gonna come by default, and you can just check that. So if we just select zone and UN rate, it gives us that, but also gives us the geometry at the end by default. And then at this point, we can just export this to file. So let's add a pipe. Now, what function do I need here to export this object, right? So let's always remember that in R, they're just objects. They're not files yet. How do I turn this object into a file in my system? In this case, this object, just to remind you, is an SF object. What function do we need here? Write SF, right? So every time you're exporting something, I want you to think of write, except for ggplot. ggplot we use gsave, but everything else we need to use a write function. And as you can see, there's a whole bunch of options depending on what is it that you're exporting. In our case, is an SF object, so write SF is the function we need. Let's give it the path here. So we are right now inside of the code folder. We want to get outside of that. So // if I hit tab, we're at the root of this project. I want to go into output. If you remember, we just created a subfolder inside of output to save the shapefile files. So if you click tab again, let's navigate inside the folder. I want to call this just vrn.shp. Now, here's an important distinction. Up until now, we've been creating GeoJSON vector files, which the only difference is this dot after the dot here, right? So before we were doing .geojson. Oops, GeoJSON. If I want to create a shape file, the only difference is just that extension there, right? So instead of GeoJSON, it's just SHP, which is the extension for shapefile. Always also remember to change one of those arguments, that is the delete underscore DSN. Let's set it to true. Okay, so if we run this, so it's giving us a warning, the field names abbreviated for S3 shapefile. So it's just let's see. Well, it gave me a warning here and even an error, but it's still exported. So on your side, if you're getting some warnings or errors here, at least make sure that if you navigate, so again, our blue button here, if I go on output and vrn, I should have these 4 files there. Now, just to clarify here again, when we're exporting shapefiles, you just need to specify the actual shapefile extension, which is SHP. But when you do that, you're actually getting, in this case, four total files, including the SHP that you specified, but also a DBF, PRJ, and SHX, which are all accompanying files to that shapefile. And just to remind you again, when you share this with the grower, you will need to send all 4 files, right? If you only send the SHP, they're not going to be able to make sense of this file. You have to send all 4. And that's, again, the reason why internally I prefer to use GeoJSON, which is just one compact file and not 4 files. All right, so just a quick summary here that what we did in this exercise. We understood where to look for information on crop and nutrient-specific recommendations. This was one example with cotton and nitrogen in Georgia. If you are in the US, you're going to find these recommendations on every state for a crop that is grown on that state for any nutrient as well, right? So we talked about how to find this information if you need to. Then we defined yield potential for each one of the zones, calculated the variable rate nitrogen for both pounds of nitrogen per acre and also gallons of UAN. I guess I have 38%, but that's a typo, 28% per acre. And then finally, we exported this as a shape file. So again, this wraps up a very important part of this course, which is going all the way from having these very common, popular precision ag layers that are EOMonitor data, soil electric connectivity, and terrain, transforming them into all the way in this workflow until we got a recommendation that is zone-based, right? And all the steps in between that we've been working through this course. I think this is a good break point or stopping for a break moment in today's lecture. So I'll give you 5 minutes of break if you need to use that. And then after that, please come back because I'm gonna introduce the final project, which is gonna be about what we just finished. So yeah, make sure you're back after the break because I'm gonna introduce that and explain how that's gonna go. Let me set up a 5-minute timer here, so we come back, but at 10:37, about that time is when we're gonna be coming back.
That messed up everything. Doing that way, but using my theme map here, or that map, it's like that. Because they're so.
Oh,
close
yeah.
together.
Yeah.
And I went back and looked
All right, so let's get back here. I want to, well, I guess first I just want to say that with this workflow that again, we started all the way from yield until here is finalized. And the final project is going to be based on this. I will tell you more about the final project here in a second. And I just want to lay out the path forward as well. So the final project is not something we're going to do in class. You're going to do on outside of class on your own time. You're basically going to have until May 1st. So it's about 20 days for you to complete that. It's plenty of time. I would recommend you don't wait till the last moment because I am sure and I expect that you're going to run into a lot of code issues, and that's just part of learning. So, you know, I will be here to help you, and your classmates will also be here to help you. But if you wait until the last moment, that may become harder to help each other. And so then what are we going to be doing in class between now and May 1st is we're going to be talking about remote sensing. So on this class, I will not show you how to process drone imagery. That's something that Dr. Lacerda has a whole course on that. And if you want to learn how to collect drone imagery and process that, her class is going to be the one you want to take. Here, I want to show you, once you've collected and stitched the imagery, how can we use that in crop production? So that's what we're going to be showing here on the next exercise, is how to use drone imagery, in this case, to determine nitrogen rate. And the reason why I want to do nitrogen rate is because we can contrast doing variable rate of some sort based on static layers. So if you think about it, terrain properties, soil electroconductivity properties are static, right? They're not going to drastically change from one year to the next. Whereas, so those would be creating zones of management zones based on static layers, like we did now, this exercise that we just finished. Comparing that to creating zones based on dynamic layers, which is imagery from that season, right? So in-season imagery that you fly a drone or maybe have satellite imagery and use that to inform variable rate management decisions. So that will be our next exercise, which is going to be based on drone imagery. And then after that, we're going to explore using satellite imagery. So at some point earlier in the semester, I asked you all to sign up for a Planet research license. I would imagine that by this point, you all already got your emails from Planet saying that you have access to it. So let me take say this slowly to make sure we get this across. If you forgot to sign up for that, let me know. You can still try to sign up now and maybe be on time for when we get to that exercise. If you did sign up for the research license with Planet and you did not get an email from them with your access to their data, I would say try to reach out to them again and double check. And lastly, if you did sign up for it and you got an email back from them with your access, then great, you're basically set up for us to do that exercise in R when it comes to that. But bottom line is, if you don't have access to that for any reason, either you did not submit your form or maybe they did not respond to you, do let me know, because you will need that to complete the satellite exercise when we get to that point. And so the next steps in class are going to be drone-based imagery and using that for variable rate nitrogen prescriptions. Then we're going to use satellite imagery and look how we can use that in a production setting, also for variable rate nitrogen. If you are in a production setting, especially, flying drones across many fields may be difficult. It may be costly. So having an option of using satellite is going to be easier, cheaper. And so I do want to show you the workflow of how you would use both drone and satellite for that. And then if we have time, we're gonna do a profitability exercise based on variable rate management. So we're doing variable rate management, and then we want to test how did our management impact yield. And so if you think about it, if you're applying different levels of input, in our case, nitrogen, and then you're getting different yield levels out of those zones, you do want to compare that. So you know how much money you're making based on the yield that you're getting. You know how much money you're spending on the inputs because you have different rates and you have a cost of that input that is on a given amount. So we can use both how much you're making, how much you're spending, and do a profitability map. So you can look at a map and you can really understand, okay, these parts of the field, at least this year, they were. So let's say sometimes if you think about it, and I had a grower last year that we worked with this, where the parts of the field that maybe they were not the highest yielding, but if he got that yield, that was not the highest, but it was a good yield level, and he got there without excessively applying some inputs. In that case, it was nitrogen. When you look on the profit map, that area, even though it was not the highest yielding, but it was the most profitable because he lost a little bit of yield, but he applied a lot less nitrogen for that. So on profitability terms, he also made more money on those parts of the field. Well, that's what we're going to explore is just looking at yield maps. You know, if you as a grower, if the metric you're trying to optimize is yield, then, you know, it is what it is. But sometimes you can get very high yields that are not profitable because you're applying so many inputs, or maybe less profitable than you think they are, because you're applying so many inputs to get those high yield levels that is just not making sense. So looking at profitability maps is something that if we have time towards the end of the semester, we're also going to explore an exercise with that and be able to make maps where I know exactly how many dollars I made per acre on each one of those cells that I'm looking at, and understand, okay, maybe here in this part of the field, I'm consistently making a profit. And maybe there are parts of the field that you're consistently losing money. Year after year, you're spending more than what you're getting back on yield and price of crops. You know, and that can be a very important layer as well, because if you know there are parts of your field that you're consistently losing money, there are two things you can do. One of them, you can try and understand why that is, right? Like, is it something that I can manage? Is it maybe because I have a very low pH and didn't know? I can fix that and maybe get those yield levels higher, get higher profits in the future. Or maybe it's something that is now manageable, right? Maybe it's something that, well, maybe I just have a very heavy texture soil there that does not seem to have good crop germination after I plant. So year after year, I have poor germination, I have poor stand, and that is limiting our yield. Then you can do two other decisions. You can maybe decide to not use as many inputs in those areas, and so decrease your cost. Or maybe you can just decide to not crop that at all. Maybe you transform that into a conservation practice program that you get paid by the government to not crop a part of the field, and then at least you get paid something without investing much, right? So there are different ways we can look into this, but a profitability map is the layer we need to make this informed decision, and not necessarily yield. So that's potentially the last exercise we're going to do in class. So looking forward to the next month or next 20 days, we're going to be looking at remote sensing and profitability maps potentially. All right, now let's talk about the final project. I think I have, let me see. I think I have pushed to GitHub last night. Let me double check. Yeah, so I have pushed last night to GitHub this new folder called 09 Final Project. You're gonna have to download that to your computer. That's gonna have a few, so there's gonna be a boundary folder, which has a shape file. It's gonna have a yield data from 1 year in CSV. It's gonna have an elevation CSV file, a soil EC CSV file, and a QMD with project instructions. So you're gonna need all those files to complete the final project. I want to show you on my computer how that looks like so we can go through those details. I will launch here the project instructions.qmd so we can talk about it. All right, so this is I'm setting up a case study for you where you can read in more detail on your own afterwards, but really it's just, is this story about a person. Her name is Natalie Rojas. She was a student of UGA and she took some of the Precision Ag classes here. And she was interested in applying these concepts to her farm, but she does not have the time to do that herself. So she's hiring you to do that for her. I set up here the problem as far as, what is her field, what is her crop, if it is irrigated or not. In this case, I'm saying it's irrigated. And I'm giving you some details that you're gonna need to consider at different points of this project. So for example, she is giving you 4 layers of information. That includes field boundary, corn yield in bushels per acre for 1 year, soil electric conductivity and elevation. And then this is some history about this field that she's providing you data for. So the next crop that she's gonna plant is gonna be corn. The previous crop was peanuts. The levels of phosphorus and potassium for this field are very high and pH is about 6. So this is just the story. Please do read this in more detail on our site when you start it. I give you some directions here. So one of them on the personal information, I do want you to fill your name both on the YAML of the script. So remember the YAML is this first part of the script that is fenced by the 3 dashed lines. This is the YAML. I want you to put your name here, first and last name. And then I'll give you some suggestions here on how to do this project. So in class, a lot of the steps that you are going to be asked to do for the final project, in class, we did as multiple RStudio projects, right? As you remember, going from, I don't know, maybe 0 to something all the way to 11, which was the management zones we just finished. So the way that I would recommend that you set up this project, the final project, is you create a folder in your overall folder of the course. You name it something like final project and your initials, or maybe a last name, something like that. You do go in there, create data, code, and output. You move this script, this one called, I guess so you would move this script project instructions inside of the code folder, which I guess I say here. You would move all the other files that are not this script into the data folder, as those are all data coming in. And then you create an RStudio project as well on this folder for this project, just like we did in class. The difference here is that instead of having one RStudio project and setup of folders for each step, you're just gonna have one overall RStudio project, where on the code folder you have the instructions, but you're also gonna be copying and pasting the scripts that we developed in class to be inside of this code folder as well. Right, so I'm just saying here, the workflow that you're going to be required to do involves all the steps that we've done, starting with wrangling and cleaning your data, all the way to creating zones, potentially a variable rate nitrogen prescription zone. So again, if you're going to have one overall RStudio project, where in the code folder, you're going to have all the codes that we did in class, and you're going to adapt those codes to this case, which has different data, different column names perhaps. So you have to adapt that. I do encourage you to do the fall. I know that you're going to be tempted to just copy a script. So let's say copy the EO wrangling script, paste that inside of this project, and just try to run that very quickly and not even pay too much attention. you're gonna have to pay, especially pay attention at the beginning, because some of, gonna have to bring in a different file, we're gonna have to, maybe gonna have different column names in that file that you're gonna have to adapt. But I also encourage you to think of what each chunk is doing, what perhaps each line of code is doing, because that's gonna help you, give you the chance of reviewing what you learned, applying to a different data set, and making sure that you understand what we did in class. Because I know in class sometimes, you are copying a lot of the code I'm telling you, so you may not be completely thinking of what I'm saying, just copying things. This is a chance for you to revisit that and really make sure you understand the process one more time. Yeah, so I suggest you have a separate Quartus script for each step, as we did in class. And also, again, in class, we created a whole new RStudio project for each step. Here, I encourage that you just have one RStudio project and just bring different code scripts inside of the code folder. All right, a very important step here. I am sure you're gonna run into issues. I expect that to happen. And it's gonna be part of your learning process. So I tell my students in my lab and students that I teach in class that, there is this balance between struggle and learning. You should be struggling about 20% of the time. That's where you're learning. If you're struggling less than that, then you're probably not being challenged enough to learn more. If you're struggling too much more than that, then it's probably becoming frustrating. So I do expect for you to struggle some, maybe more than just some. And when you struggle and you need help, I'm sure you've been doing this already in this course, but I want you if you have questions that you're running into code issues and you're not being able to fix it by yourself, first thing is to go to Google. If that's not helping you, you can use our GitHub repo for this course and ask questions under issues. I do expect you all to use issues a lot, both to ask questions, but also to help others and answer when someone has a problem that you know how to fix, right? I do not want you to email me with questions about the project unless they're very specific to you, like personal types of questions. Yes, you can email me. I don't want you to be posting sensitive information on issues on GitHub. But if it is about the project itself and code issues, do not email me. Use GitHub issues for that. If you have not done that yet, you can watch the repository so you get notified when someone posts on issues. This is going to be both for you to help others, but also if somebody's helping you, you get notified when that happens. So on GitHub, I'm just gonna come here to 2024 PPA. You can, let's see, watch, right? So I am watching. So if it says unwatch, the option unwatch, if it shows you watch is because you're not watching yet. So make sure you watch that GitHub repo so you get notified of when somebody posts something new on issues. Let me see, where was I? Okay, so this, you're gonna run into issues. This is just a sequence of steps that I would follow. If you have issue, try to first figure out yourself. Sometimes the error messages you get are informative, so make sure you read them. Just because you get a very long message of error, don't just dismiss it. Try to see if there's something you can interpret from there. Sometimes it would say something like error, object, yield could not be found. That's should be pretty self-explanatory, right? If that object cannot be found is because you have not created that object. So maybe you're naming something else, or maybe you forgot to run a chunk, right? So try to interpret that. If that doesn't help, you can Google it. Sometimes just copying and pasting an error from RStudio on Google will help you find an answer for that, or somebody that had a similar situation. If that doesn't help, go to your peers. So use GitHub to ask questions. And if none of that has helped, then reach out to me. I mean, it could even be on GitHub issues. You can tag me on a given issue and say, hey, Dr. Bass, can you help me out here? I will be glad to go there and try to see if I can help you. If I cannot help you on GitHub, we can set up a one-on-one Zoom meeting, in-person meeting, whatever it is, and I can help you that way as well. All right, so turning it in. I do want to stress this, that I'm giving you a lot of instructions and I do expect you to follow them, right? So sometimes it's something very silly, like add your name. I cannot tell you how many times this semester inclusive, I ask add your name on the YAML, and some students forget to do that. It is silly, but it's something that adds extra effort on my side when I'm grading. And so if I'm asking you explicitly to do something on the script and you don't do it, you forget it, you will lose points for that. So what do I want back from you? What I want back from you is this script that you're seeing. I do not want you to send me all of your QMD files, all of everything that you did from beginning to end. I want you to still use, you're gonna have to do that on your side to get to the answers I'm asking. But what I want you to send me is this script that you're looking at with the answers that are based on what you developed using the other scripts. Okay, so this is the script I want you to submit to me. Do not remove any of the text I have here, so leave all this in. That is gonna help me when I'm grading as well, so do not delete any of this extra text. I want you to make sure that when you, and I want the render version of this, so when you render, make sure that your questions appear on the table of contents of that HTML. Right, so the same way they're appearing here, I want them to appear on the table of contents. Again, that helps me to grade. And this script here, I do not anticipate that you're gonna run analysis code. This is just where you're gonna bring in the results of what you found on the analysis scripts that are different from this one. So this is a project. It is, a large project that I will expect you to use your answer with full sentences, proper grammar, very professional, right? So if you don't do that, you will for sure lose points for lack of professionalism. So make sure that you do that on your side before you submit. A quick tips here. So because you're not going to be creating maps in this script, how are you going to be able to show me when I ask you to show me a map or a plot? What's going to happen is on the script that you do create that plot or map, you will export that with, let's say if it's a ggplot, you're going to use ggsave to create a PNG file on your file system. Let's say on your output folder. So let's say that in some script, you created this figure called figure1.png. Then you're going to come on this script here, and you're going to just use this approach, assuming that you have a figure1 inside of your output folder, so a figure1.png file. This is how, using this notation here, is how you would embed a figure here. So you create a figure, export that as PNG, and then I just want you to bring the PNG into this script, not the code to create the figure. I want you to give descriptive titles to your figures, and your legends need to be professional and include units. So if you just give me a legend saying yield, not professional, right? I want yield parentheses bushels per acre, or whatever it is. When you're using color, use a colorblind friendly scale. If you want to bring a data frame to this script, so let's say that you create a statistical summary that is just a data frame in that script. You can, on that script that you have that data frame object, you can export that as like write CSV, for example, have that file as a CSV in your file system, like in your output folder perhaps, or data folder. And then you can read in that here. So it's going to be a little bit of code, but not to create the table, just to read that table in and show me the table, right? So on the script that you create the table is just a data frame. You export that with write CSV, and then you can import the CSV afterwards in this script using a read_CSV, for example, to show me just the table. Something that we talked about this on the mini project is I want this render version to be very professional. So I do want you that if you have chunks that are printing 4,046 rows of data, I do not want to be scrolling through 4,046 rows of data. So use the head function to just show me the first, 6 or 10 rows of that. That's going to be enough for me. If the chunk is creating warnings or messages that really are just cluttering the output, You can inhibit that by using this notation here on the beginning of the chunk. We've seen this before already, so this should not be anything new. There are some scripts that I have this included, so you can use that for reference as well. And when you do include code on the script, I do not want to see that code when you send to me on the render version. The reason for this is I want you to think of this render version as the report you would share with Natalie. So she does not care about R, she does not care about programming languages. She just wants to know about the questions that she's asking you and your answer to them. So I do not want to see your code on the render version. And when you render, make sure that you check how it looks, right? Because sometimes it may look weird. And if it looks weird, I want you to fix that before you send it to me. Again, you're going to be graded on that. Grading. There are some questions that are extra credits. If they are extra credit, it means that for undergrads, I think, Doug, you're the only undergrad in the class this semester. It means that if you don't want to do them, you don't have to. But if you do them, you're going to get extra credits. However, for graduate students, you are required to do that. They're not extra credit for graduate students, just for undergrads. Your grade is going to be based on answering correctly the questions, and make sure you answer all parts of the question because some of them are composite questions, that you follow all directions, that you use proper grammar, that you have professionalism of your render file, that you use GitHub to both ask questions and help others. So this is going to be part of your grade, right? So if you are seeking help on GitHub, and especially if you're helping others that seek help on GitHub, that grade is going to be also an influence on your grade. And then, of course, turning in on time. Then I have here the questions part. I think there are 22 questions. I'm not going to go through them one by one, but they're here. You know, something, I guess, just to make it clear, when you are answering questions, if you need to add a chunk here to bring in something or to show me something, you can add a chunk. I don't want to see the code, but you can add it here. When you are answering something, you can just write normally here, right? So if it is outside of a chunk, you can just write normally here, as you would in Word. One thing that I want to caution you here is that on the script, if you're writing multiple lines, you're just hitting it return once, like I did here. So return, write something, return, write something. When you render it, these sentences may all be connected on the same line and not be broken on different lines. If your intention is to have them on separate lines, a quick trick here is just, instead of having just return, you actually do a space, space, return. That double space is what breaks line on the render version. Very easy. Just remember that if you render and something that you thought you wanted in two separate lines is together, just add 2 white spaces at the end of the one that you wanted to break line. That's going to break line on the render version. All right, so again, all I need from you is this script here. Once you have it done, your deadline to submit to me is May 1st, 11:59 p.m. You can submit earlier if you wish, but that is the final deadline. And I have some code tips here as well, just overall. So if you're running into problems and it's data importing related, check that the path you're specifying is correct. Check that you're using the proper function depending on the file type. So if you're bringing a CSV, you want to use read_CSV. If it is a shapefile or vector geospatial data, you want to use readsf and so on. If you're importing a shapefile, you want to specify the SHP file of all those. If you are copying code from class, which I do expect you to do, and you run into issues in a chunk that has a pipe flow. The way that I troubleshoot my pipe flows is, so let's say I run a chunk that has a pipe flow, I have an error, I don't know where exactly the error is happening, what function of that pipe flow is causing the error. What I would do is go line by line on that pipe flow and stopping the flow at one point using the hashtag right before the pipe, running until there. Did it run? Okay, the problem is not with those first 2 lines. I uncomment the pipe, let it go to the next line, and add a hashtag on that 3rd pipe and stop it there. And do that consecutively So you can identify which one of the functions giving you the problem, then it helps you to troubleshoot that. All right, k-means, you're gonna need to do create zones, so you're gonna be running k-means. I will recommend that when you're determining the number of clusters, that you use the within sum of the squares and the silhouette width techniques to determine that number. I do not recommend that you run the nbclust function on this case specifically, just because when I tried to run on my side, it took a very long time and it crashed and I would never go through. So I just wanted to say that if you don't, you can just determine the number of clusters with those two techniques. You don't have to use nbclust, which is that one that does, I don't know, close to 30 indices for you. And then lastly, as a tip, if you're exporting spatial data to file, remember to use the right SF if it is a vector geospatial file, and to always include that delete DSN equals true as part of that. So you don't append, you overwrite in case you run this twice. All right, so that's what I had for the project. Before I open for questions, if you have, I will just get your attendance. In case you need to go, you don't have to stay for questions if we do have questions. Right, attendance, April 10th. You can claim your attendance. After that, you're dismissed. But if you do have questions, I'll be here for a moment and I'm gonna open for questions right now. Any questions? All right, I don't hear anything, so I guess that's a wrap for today. Just a heads up, I believe I have the workshop that I'm part of this Friday as well. And in that case, I will send you instructions and data and partial scripts and video links for you to still go through the exercise of variable rate nitrogen on your own. But we may not meet in person. I'll send an email with more information after class here. All right, so if no one has.
Dr. Bastos,
Yes,
I have emailed you regarding the current assignment that we have. Is the deadline 12th?
sorry, Kumar, I cannot hear you well. Can you?
Okay, I'll repeat it. I was asking that regarding the last assignment that we are currently in, I think assignment number 8, the deadline is on April 12, right?
That's right.
Or like, yeah, okay, good, thank you.
All right, any other questions? Okay, so that's a wrap then. I'll may see you on Friday, but if not, I'll send you an email with instructions for covering Friday's class. And if nothing else, I'll see you next Monday. Thanks, everyone.
Thank you.